We are going to start chapter 17 in this video lecture, which is on alcohols. Chapter 17. It talks about alcohols and phenols. This is an important chapter because alcohols can be starting materials to a number of important organic compounds. So let's start with the structure and some properties of alcohols. So what are alcohols? Any compound, organic compound, which contains a hydroxyl group, an OH group, and its name will end in ol. Like for example, this is a 2 carbon atom parent, and this will be called as ethanol. A hydroxyl group occurs in a large number of compounds. If you check any most of the pharmaceutical drugs, you can see that OH is one of the common functional groups. Like for example, we have an antibiotic, chloramphenicol, or cholesterol that has OH groups present in it. Phenol is actually a special kind of alcohol, and it has a hydroxyl group which is attached directly to a phenyl ring. Okay, so this one is phenol. We'll talk about phenols later, but we will look into some of the namings of alcohols first. So for the nomenclature part, we will follow the IUPAC system again by identifying the name of the parent first, and then we will name the substituents, and then we will assign a locant to each substituent, and then we will assemble all the substituents alphabetically. Okay, so for example, if you have something like this structure, so you can start numbering from either side in this case, because it's will give you number 3 to the functional group. So here this compound will be named as 3-pentanol. Another way of naming this would be pentan, then dash 3-ol. If there is a chiral center in your molecule, then make sure that you assign the chirality or the absolute configuration at the chiral center. So for example, if I have something like this, a compound. Now here you can see that this carbon is a chiral center, so this will be a 3 carbon atom chain with the phenyl as one of the substituents, and we have let's put a chlorine here, Cl. Okay, and at the second position we have a chiral center here, and at the first position we have the OH. So you have to give the lowest number to the chain bearing the functional group. So we have this 1, 2, 3. This compound will be named as 2-chloro, and then at the third position you have the phenyl ring, so 3-phenyl propanol, or 1-propanol. However, we also need to identify the chiral center here. So if you look at this, has a R stereochemistry, so this will be named as R2-chloro-3-phenyl 1-propanol. Okay, if you have a cyclic compound, then make sure that you include the parent name as part of, which is the ring. So for example, this is a 5-membered cyclic ring, so you will call this as cyclopentanol. Oops, I didn't put the OH group here. Okay, cyclopentanol. We have some common alcohols like methanol. They are more commonly known by their common names. We have methanol, which is toxic actually, and it can cause blindness and death, and even in small quantities. It's actually obtained from wood. It's also called as wood alcohol. It's an important compound, this CH3OH, that is methanol. It is the starting material for the preparation of acetic acid, which is vinegar, and also formaldehyde. So it is one of the important compounds. Another common alcohol that we are familiar with is this ethanol, which is obtained by the fermentation of grains. This is the drinking alcohol, and also it is used as a solvent. So we will be using in many experiments ethanol as one of our solvents. This is also a very important starting material for a number of important organic compounds. Okay, you can obtain denatured ethanol, which means that you can add a small amount of methanol to make it contaminated, so that it is not used for drinking purposes and it is only used for maybe industrial purposes for preparation of other compounds. So that is called as the denatured alcohol. One common method which you have studied earlier in 235 to prepare ethanol is by the catalyzed dehydration. It's catalyzed hydration of ethene or ethylene. Okay, we'll look at the methods of preparation shortly, but just reminding that we have studied some of the methods of preparation of alcohols in Chem 235. Okay. Now regarding phenols, you all are probably familiar with the disinfectant, right? So it is used as an synthesis of important compounds. And another common alcohol that we come across usually is isopropyl alcohol, which is also called as the rubbing alcohol. So this has antiseptic properties. So it's also called as the rubbing alcohol. And this is also prepared industrially by the hydration of, or the acid catalyzed hydration of propylene. Okay. It's a local antiseptic. We use it also as a industrial solvent. Okay. So this is some basic idea about the alcohols and phenols and their namings. Let's look at some of the important physical properties of alcohols. Alcohols have much higher boiling point than many of its comparative analogs. So for example, if you compare a 2 carbon atom compound like C2H6 and C2H5OH is our alcohol analog of that, you can see that the boiling point of ethane is around minus 89 degrees Celsius, whereas the boiling point of ethanol is 78 degrees Celsius. So you can see the big difference between the boiling points of an alcohol and just a hydrocarbon with the same number of carbon atoms. So the reason that why alcohols have such high boiling points is because of their very strong intermolecular forces of attraction, particularly having hydrogen bonds. Okay, so alcohols form hydrogen bonds because of the presence of OH covalent bond in them. Therefore, most of the alcohols have higher boiling points. They are also the alcohols with shorter hydrocarbon chain. They are miscible in water. Like for example, ethanol is miscible in water. But if you have a long chain alcohol, like for example, if you have something with several carbon atoms in it, carbon hydrogen atoms in it, then this becomes less soluble in water because it has got a more hydrophobic region than the hydrophilic region. Okay, so that's about the boiling points. Another important property of alcohols is their acidity. Okay, acidity, that means they can behave as acids. Both alcohol and phenol, they can behave as acids, and their if you write down the reaction of an alcohol with a base, so for example, if I write ROH plus, say if I call B as my base, then it can pull off this proton, put these electrons over here, and we get the conjugate base, which is the alkoxide, RO minus plus, let's just make this as BH. Okay, so the base grabs the proton. So the conjugate base of the alcohol is called as alkoxide, and the alkoxide is much more stable than its parent alcohol because oxygen can stabilize this negative charge. Therefore, they can act as acids and donate a proton. Okay. They are not very strong acids. Generally, their pKa is like between 15 and 18. So you do need a relatively strong base in order for the acids to act as in order for the alcohols to act as acids. So one of the common bases that we use is sodium hydride. So you can write down a reaction like this. So if you have an alcohol with a base like NaH, this is sodium hydride. So this is Na plus H minus. This hydride can grab the proton here, put the electrons back over here to give our ethoxide conjugate base, and the sodium now remains with this negatively charged species, and then you get hydrogen, which can be bubbled out as a gas. Okay. So this reaction exhibits the acidic nature of the alcohols. Another factor which makes like for example phenols a powerful acid, again relatively speaking, okay, when I say powerful, its pK is around 10 and little bit more than or a little bit lower than that of normal alcohols. The reason why phenol is a stronger acid than, say for example, ethanol, so you compare this with this, the ethanol's pK is around 15 and the phenol's pK is around 10. So that makes this a stronger acid than this alcohol here. So the reason is that the conjugate base of phenol, which is the phenoxide ion, so after you remove the hydrogen or the proton, what you get remaining is the phenoxide ion. This can actually exhibit resonance structures, which makes it more stable. So you can draw the arrows to show the resonance structures. So the conjugate base is stabilized by resonance structures, which makes the phenol a much more stronger acid than that of ethanol, because ethanol's conjugate base, which is the ethoxide ion, does not exhibit any resonance structures, right? So you can actually keep on going and draw some more resonance structures for this. So for example, this one has the third resonance structure where your negative charge is now residing on this carbon atom. You can keep going for one more and you can draw the structure like this, where you have the negative charge now on this carbon atom, and now you have the last one where you can put this back, this pair of electrons goes over here, and you get the final structure, which is with the oxygen again taking the negative charge. So you can see that there are number of resonance structures which stabilizes the phenoxide ion, hence phenol is a stronger acid. Sometimes you may be asked questions regarding alcohols with more electronegative groups and to compare their acidity. So for example, if you have an alcohol like this and an alcohol with a chloride group on the adjacent carbon atom, then this compound, the second compound, would be more acidic than this one because of the inductive effect. So the pKa of this one would be lower than the pKa of this, again because the chlorine atoms being more electronegative, they can show inductive effect, as a result of which this proton can be given off much more easily as compared to this compound. Okay, so you have to keep in mind these factors when deciding about the acidity or comparing the acidity of various alcohol molecules. Okay, All right, in the next video, we will talk about some preparation of alcohols, which you have studied in your Chem 235. So we will review some of those, and in another video, we'll talk about some of the new reactions which will be introduced in this semester. For example, preparation of alcohols from reduction of carbonyls, etc. Okay, all right.